Section 2.5, linear equations. So basically linear differential equations. So we say a first order linear differential equations can be written in the form a of x dy dx plus b of x y equals r of x, and defined over the couple AB provided a of x cannot be 0. The main thing here is to learn how to solve linear differential equations. That's what this section is about. So the first thing we do is we always divide everything by a of x. Make sure the main coefficient in the front is 1. So plus b of x over a of x y equals r of x over a of x. We may rewrite this as dy dx plus, we can write this as p of x y equals q of x or f of x, whatever you like. And this is called the standard form. It can be solved by rewriting it as d dx of some function in xy equals, say, g of x. And then I'll come back and give you another trick in a minute. For example, if we are asked to solve dy dx plus 1 over xy equals 5x squared, where x is bigger than 0. So it's given in a standard form, just in case if we multiply by x both sides, this x, we would get 5x cubed. Then by guess and check, we need a function. If we differentiate, it gives me the left-hand side of the last equation. What would that be? Well, they have x in the front and no x later, so there's an x here times y. See, by the product rule, you will get this part. For now, we're gonna say by guess and check, that's what I'm doing. If we integrate both sides, the integral will cancel the derivative on the left-hand side, and the right-hand side we get this, 5x cubed dx. Keep this the same, 5x to the 4th over 4 plus c. If you divide everything by x, you would get 5 over 4 x cubed plus c x to the negative 1. Now we introduce what we call the integrating factor. Which will help us solve linear differential equations. Call it I of x. Or some people call it mu of x. What is I of x or mu of x? Is e the integral of p of x dx. P of x from the standard form of the linear differential equations. And so what is that? Even if I find the integrating factor, what do we do with this integrating factor? We then multiply the entire equation by the integrating factor. And after you multiply the entire equation by the integrating factor, we will always get d dx. Instead of guess and check, is going to be the integrating factor, e the integral of p of x dx times y equals e integral of p of x dx times q of x. Then we integrate both sides and solve. So if we need to go back and solve the same equation, it was dy dx plus 1 over x y 5x squared. Notice it's already written in a standard form. So they made it easy for us. What we have to do first is to find the integrating factor I of x, e the integral of p of x dx. P of x is 1 over x dx. The integral of 1 over x is natural log of x. E ln of anything, so E ln of n is always n. Provided n is positive. So that gives me x. After we found I of x, we multiply the entire equation by x. X dy dx plus y equals 5x to the fourth. Then we do d dx of the integrating factor times y all the time equals the integrating factor times q of x, or any function there. So d dx, I of x is x, and I of x is x. And notice you can integrate both sides. Let me scroll back up. That was 5x squared. That should be cube. Because q of x is the one before we multiply by x. And then from here, we finish it the same way as we finished the other one. And then divide by x. Another example. Can go over this now. Notice it's already written in a standard form. So all we need to do is start with this is p of x, this is q of x. Start by finding the integrating factor I of x, which is e, the integral of p of x dx. E, the integral of 2x over 1 plus x squared. Don't forget the dx. And what do we get here? If you take the bottom one u, the top would be du. So it's going to be e, the integral of du over u. So it's e natural log of 1 plus x squared, which is 1 plus x squared. So we're going to multiply both sides of the equation by 1 plus x squared. So 2xy equals 1 plus x squared over, and there's a 4 there, 1 plus x squared square. So this copy cancels this. And always is going to be d dx of the integrating factor 1 plus x squared times y equals 4 over 1 plus x squared. Integrating both sides, 4 over 1 plus x squared dx. Don't forget the dx.
Professor, what happened to the 2x when you factored out the d over dx?
What happened to what?
To the 2x on the
Well,
left side.
if you do this way, product rule, you will get the 2x from this one.
Then it'll cancel.
It's not cancel, but if you find the derivative of this using the product rule, you will get this.
Oh, is that the integral of it?
That's the derivative of 1 plus x squared.
Okay. Oh, I see now. Okay.
So this stays the same. You take the 4 out. The integral of 1 over 1 plus x squared is tan inverse of x plus c. Then you may divide everything by 1 plus x squared. So 1 over 1 plus x squared times all of this. Another example. Solve dy dx plus y cotangent x equals cosecant of x. Try this one. The integrating factor, this is written in standard form. I of x is e to the integral of p of x dx. P of x is cotan x dx. And it shouldn't be difficult to integrate cotan x by rewriting this as cosine x over sine x. And you can let u equal sine x. So this is du over u. So natural log of u, like that. So this gives us e natural log of sine x, which is sine x. Then we multiply everything by sine x, the given equation, both sides. Cosecant x. And what we can do here is keep this the same for now. We can rewrite this as cosine x over sine x. These cancel. So y cosine x. This is 1 over sine x. Cancel is 1. So now we can rewrite this by taking the integrating factor times y equals 1. Integrating both sides, the integral of 1 dx, sine of x y is x plus c. Then we divide everything by sine x to get that. You can leave it like this, or 1 over sine is cosecant. If they ask you to solve an equation with initial condition, all you have to do, just when you get to this point, like the box form, you can use that condition. You can use that condition to find the value of c. I don't know, let's come up with a number here. If y of pi over 2 if y of pi over 2 equals pi over 2, what happens then? Well, this means this is saying when x is pi over 2, y is pi over 2. We can substitute them into this final thing. You got pi over 2 equals pi over 2 cosecant pi over 2 plus c cosecant pi over 2. Cosecant pi over 2 is 1. So that would be pi over 2 plus c times 1. So c is 0. Then you put it back in, and that gives us x cosecant of x. This is called particular solution. And the one that we found earlier is called general solution. It's called general solution. Any questions about this? So this one that I wrote there, y of pi over 2 equals pi over 2, is called the initial condition. And it should be given to you if they want you to find a particular solution. If not, whatever we got earlier, the one in the box, the earlier one, that's called the general solution for that given differential equation.